It's a late start. Can we stop the announcements? Anyway, that's how I'm starting the. Okay, so we got hey, good foilers, say it. Good factors. Now we're going to use trig and factoring to solve, which is just one extra step to the last 2 days, maybe last 1 day. And I hope at some point she's done because I really don't want to talk over her. So we have 39 minutes. We are now 4 minutes into announcements. What are you checking? Did you get a message? What is that? Huh? Did you get a message? Love those watches. I can't wait for the brain implants. We already got the glasses. Are those regular glasses or are they smart glasses? Oh, you said no on regular. Are those smart glasses? Let me see. Okay. What about you? Huh? Yeah, exactly. No, I'm just kidding. Okay, 9:49. We still got announcements going on. Alrighty, now I can talk. Okay, so I don't want to do this every single question. This is how your brain's got to go. We're just going to get right into it because, like I said, we already lost about 5 minutes. Hold on, I got to move this thing. I got my face not in this because the technology can't handle it. Then it takes me 8 hours to compose a 40-minute video. I love my life. Anyway, how does this factor? 4x squared minus 1. How does that factor? Well, we know that's a anyone? Anyone? Difference of two squares. And then why is it plus minus? Because we get no middle term. And this is the whole point of good FOILers, good factors. I'm not a good factor. Let me check. Yes. Oops, sorry. Gone. Those two are opposites of each other. And then yes. So yes, that's good FOILers, good factors. You're a fool if you do not check, if you're not confident with your factoring, check the answer. Does it multiply to be the question? Then I can move on. All right. And that's the last time we are going to cover like how I'm supposed to see trig comparative to this. Well, actually, I'm a liar. Because you know what else we could do, which I think we leak into this tomorrow as well. Some more of this, I believe. But again, on a Wednesday, my mind scrambled by the 153 things I went through in our 2 meetings because that's what we do. We just, talk about so many different things and blah, blah, blah. But I think we have something like this going on tomorrow as well, but I may be wrong. So this one I don't really have to factor. I can isolate the squared, and then we know getting rid of squareds is square rooting. But when I square root, what are we supposed to put, everyone? You should know this. Plus or minus. So that actually is a good thing. And then let's look at the directions again. Okay, got to focus on that. So I need all answers between 0 to 2 pi. Just got an easy question. Where's cosine positive? Which quadrants? 1 and, come on, 4. And if you don't know that, you're severely and totally behind. And then where's cosine negative? 2 and 3, the other two. So if it's plus minus, I'm dealing with all 4 quadrants. Next question is, what's the angle measure? An over 3 or an over 6? You're behind if you don't know that instantaneously. It's an over 3 because sine of theta equals a half would be an over 6. So this is an over 3, right? And that's how you play the game. So it is every single over 3 that satisfies this. Here's the positive. Let me finish. This is also where I get positive a half, and then this is when I get negative a half. So I just wanted to piggyback off of why I know it's all 4 quadrants, and this is a nice one. It really is. Okay, now, again, you have to think about trig. Like variables, and I'm not going to write it, but I'll say it. This is like x squared minus x. This is the worst factoring. I don't know why people forget this. What's the first thing of factoring you should always look for? Greatest common factor, and I don't understand it these days. Students really mess up greatest common factor factoring more than any, and it's wild. It's wild to me. Good foiler, say it. Come on, that's tan squared, and then I need that minus 1 to get a minus tan back when I throw it back in. But you don't do that, you're going in circles. But you're checking, does my answer match the beginning when I multiply? Factoring is the reverse of multiplying. Opposite operations. And then we do what's called the zero product property. This is all algebra review, but just inserting trig as the variable. All right? And that's really what's happening here. 0 over, 0 over, 0 over. What's the number down there? 1 over, 1 over, 1 over. We might as well do it. 1 over, 1 over, 1 over, 1. Okay, because both of these are y over x. I'm just going to put this randomly here. By the way, x could be plus or minus because it's x. And that means I have two spots that this could happen. And where would that be? 0 for y and 1 for x. That's these two positions. Am I right? Of course I'm right. How dare you? And then this one, this is y and x. This is why you got to be careful with tan and cotan with 1. What is that? What is that an over? Is it an over 2, an over 4, over 3, over 6? What is it? It's an over 4 for tan. Because 1 squared plus 1 squared is 2, and then you square root it. So this is what I'm thinking about. I know this is this triangle. All right, and then this is theta. Even if I throw it in a coordinate plane or not, tan of theta is 1 over 1. But then I get root 2, and that makes it a 45, 45, 90. So I know I have a 45. So my answers are, I guess I'll try to go in order here, 0. And then one of these is pi over 4. And then you don't have to do this going in order. Pi, and then where else is tangent positive? Quadrant 3. I said 3 and then I wrote it on accident. It's 5 pi over 4. And if you still don't know how to find your angle measures, you know what I did before you walked in here? I checked your delta maths. And I'm pointing at you guys. All right, and if you still don't know how to find this angle measure, you are really behind. And that was the delta maths marked as H4. That's open till May 29th. And I have over half the class with zeros on that one. I know it was optional. So internal locus of control, I thought I'd throw it out there for those that struggle, that are still struggling on some of the basics of knowing where these angle measures are and blah, blah, blah. That was the design of those. And then, you know, the latest one, I still have 3 zeros on the latest timed that I did in front of class one day. And then I think I did it again and opened it up one more day to get those that had zeros on it as well. Still have 3. 3 stragglers on that are not training themselves properly. So let's go. All right, so now I'm trying to force the external locus of control. I'm watching you. All right, so if you are struggling, there's one thing to say, I don't really need to do that. There's another thing to say, not doing it and still being slow and not knowing your ratios good enough and knowing your unit circle values and evaluations, because that's going to keep coming. All right, so you saw what I did. I subtracted 1. Now this is, okay, fine, I'll write it one more time. We have to look at this like this, where cosine is the variable, not x. And all of us know that we can factor that, so we can factor this in the same way. Good foiler, say it? I'm sick of saying it, all right? So some people didn't say it. So I know it's going to be 2 cosine and 1 cosine. Why? First in FOIL. This is 2 cosine squared then, and then that matches this. So this is how I factor. I check as I go. Now, there is, I mean, come on. You have 3 positive with a negative as a middle term. That just means you have 2 negatives, because 2 negatives multiplied together equal positive. Simple. All right, and then I have 3, so it's got to be 3 and 1. But my middle term is -7. So what do you think has to go right there? 3. That's how you do factoring. That gets me -6, and then this gets me -1, which is -7 cosine as a middle term. All right? So I'm going to erase that. I just wanted you to see how this factors, and good FOILers, good factors covers everything. This multiplies to be that question. So, of course, this is the factorization of this. All right, and then add 1, divide by 2. Oh, no, this is interesting. Forgot this happens. What? 3 over, just say it. 1 could you have, let's go back to old school. Could you have an adjacent side larger than the hypotenuse? No. So this is a no solution. This is not extraneous. This is just not, it factors, but as far as trig is concerned, that's not a triangle that exists. It's impossible. And then cosine of who is 1/2. It's an over 3 or over 6. We already had that. This is the repetitiveness. This is why I really question you that you don't know that's an over 3 right away. And then it's quadrant 1 and 4. All right, because sine of a 30 is 1/2. So sine of theta equals 1/2 is the over 6's. It switches for the cosine. So I'll keep repeating that. And if you're legitimately doing your homework, your evaluation should not be that hard. All right, and you know that, those that are doing it appropriately. We just had our math meeting today. We were lamenting about how many students still copy keys. It blows my mind that this is still a thing. Blows my mind. And we know it. We can't fight it anymore. I don't know if it's happening in here, but we know those that, I went back to the beginning of the year talking about charlatans. That is charlatan, fraudulent behavior. Copying keys, copying homework from your friends, not even thinking about what you're writing down. What do you think the result's going to be? And that's really we had a lot of discussions about that today, mostly about the A-Bers. But, yeah, we're doing graphing right now. The graphs are pristine. Then we go to a written test and they leave it blank. How's that possible? All right, we know what it is. Where's tangent negative? What quadrants? Where's tangents negative? And you just see I just used the zero product property, right? It's as simple as that. You set each one of these equal to 0, and then you solve, subtract, and divide. All right? So where are they negative? 2 and what? 2 and 4. And then what is it? Well, I know we struggle with tangents, so this is always what I do. I go back to the triangle, and then I know y is the reference angle side. Who is opposite 1? Is it 30 or 60? It's a very easy question. We should know the answer. It's 30. So these are 30s in 2 and 4. It is easy, and I don't care what anyone says. All right, and we got to make it easy. I have written this triangle almost every time, as picking a lane. Pick a lane and how you figure this out. And that was the first day that we did trig. We did a breakdown of 30, 60, 90s, and 45, 45, 90s, probably a month ago. And then I've been referencing it for a month. All right? And then some of you should just have it memorized. Tan of theta equals root 3, 60. Tan of theta equals root 3 over 3, 30. All right? And that's just from rote memorization of writing this over and over and over again. Do something. Or do the hand. I wish we had the picture here of me doing the hand here. Here's 60. That's root 3 over 1. Here's 30. That's 1 over root 3. All right? And then that's why it's root 3 over 3. That's why it's a 30. Another reason. 3 different ways I just covered this. One is rote memorization. All right, so it's the over 6's. So that's 5 pi over 6, short 6 pi over 6. 11 pi over 6, short 12 pi over 6. And then I'm not going to worry about order here. Then get this one. Come on. What's root 2 over 2 for sine and cosine? 45. And then what quadrants are you in? 3 and 4. So, and then sometimes we draw the triangles, but we should already know this. So it's the over 4's, and that is in 3 and 4. Sorry, that's 7. My brain kind of glitched there. There's no rule about having to write them in numerical order. Just solve one, solve the other, put them in a solution set. All right? So 0 to 2 pi, we like those for this. Okay, here are some more, identities. And I think we know this because I've always said, I won't say it because I don't want to get in trouble. Sine is so, we know what cosecant is. But that just means they're reciprocals. So this is maybe another way of writing this. So this is the beginning of highlight this. Because we're in the future, we just looked ahead the next 2 quizzes, or maybe 3, slash tests, whatever you want to call them. Now we're going to leak into identities, which identities are trig expressions that are equal to each other. And then what we can do then is replace We could substitute. All right, and that's where your world is going to be coming, especially on the next page. So we know this is true already. We just had it in a little different format. The format was sine is sur. So that means cosecant is y over r. Or r over y. Sorry, I said that wrong. Right? And that's just saying the same thing. They flip. So it's just another way of writing it. All right? So, because here's where we got a problem. Look at this. How do I deal with two different trigs in a question I really cannot factor? So what I could do is a couple things. I could say, all right, at least I know this. Oh, and then whenever I see a fraction equals a fraction, I could cross multiply. And then this turns into 1 over here equals sine squared. Okay, I can handle that. So that's how I get these trig functions to be the same trig function, putting them in terms of the same trig function by replacing something that is equal. Since I see up there cosecant's equal to this, I could substitute it. This is the whole idea with trig identities. You're going to have to do this a lot in the future in a different set of questions. And then how do I get rid of squared? What do I do? Square root. When I square root, what do I got to do? Plus minus. You don't do the plus minus, you're severely totally behind again. We mention this all the time. It's been very recent too, unless I'm thinking about AB. It's hard to remember everything. 1 over, 1 over, 1 over, 1. And then that means y is 1 and r is 1. So that means x has to equal 0 to fit the Pythagorean theorem. Where do you have 0, 1 and 0, negative 1? What two positions? Up and down. You got it. And it's pi over 2 and 3 pi over 2. So careful with 1 and 0 for all 6 trig functions. They are unique answers. For tan and cotan, that's 45s or over 4s. Sine and cosine, you're on some sort of quadrantal. 0, 90, 180, 270, 360. I like saying it in degrees because we do know the degrees. And then careful, when you get 0, you could get some undefined values. And we know that for the other 4. Okay. Now, the reason we have this graph, it's kind of goofy, but I'm going to use it a little bit and just come up with some things that you may already know. Well, like number 1, I could do a quick sketch of sine. And then actually, if you've watched any of the people on Flip Math, they do it that small. You know, they do write the sine curve as 2 bowls like that. But if I continue, then it's like this on the other side, right? And then I just have one little thing, and you'll remember this. Well, that's not a good one. Sha-na-na-na-na-na-na-na-na-na-na. Oh, there we go. Sha-na-na-na-na-na-na-na. What is that noise for? Symmetry. And who am I symmetry with respect to? Starts with an O or origin. Very good. They did well on that. All right. And then what does that mean? The function is odd. So these are actually called even odd identities, the negative angle identities. Even odd identities. They are. Actually, our old book called it that. Many books call it that because it's true. So since sine is odd, here's what happens. What's the sine of 30? Just verbalize it. 1/2. What's the sine of negative 30? Not a half. It's what? Because you're in quadrant 4 for that. All right. And then I just kind of I use this grid just to show and I'll change colors for cosine. And so for this to be true, I'd have to snap a negative in front of this, and then that would be a true equal sign. All right. So what we're saying is this is the odd test anyway. If you go back to your notes when we first taught you even and odd, you may have learned it last year though as well. So maybe refreshed your memory. When you throw a negative x for x, you end up with the opposite function. Now, I know I said x and that's theta, but I was talking about our notes when August, probably September. Even odd was probably pretty early. All right? And then I'm sure you did it last year. And then I could just ask simple, and I'm just going to change the angle measure just to move it. What's the cosine of 60? I made it easy again. What's the cosine of 60? Half, because sine of 30 is a half. So when I switch to 60, the half and the root 3 over 2 switch. All right, but then what's cosine of negative 60? What's the answer to that? You're in quadrant 4. What's the answer to that? Is it negative or positive? It's positive. When you're in quadrant 4, then this is the same as this. So that means this is the same. You know why? Cosine is even. Cosine kid? Cosine kid. Sha-na-na-na-na-na-na-na-na-na. Sha-na-na-na-na-na-na-na-na. That's symmetry about the y-axis. And that was the test for even. The test for even was when you plugged in negative x for x, no change. You get the same exact function that you're left with. All right? And then the last one's tangent. Let's play with 45, let's say. What's the tan of 45? What is the tan of 45? I just went through this. 1. What's the tan of negative 45? Oh, I picked blue. What a bum. I have sine as blue up there. Oh, well. Negative. So for this to be true, we'd have to throw a negative in front of this. So that makes tangent odd. And you know what? It's so easy to see tangent as odd. Asymptote, asymptote, graph. And then maybe change colors for the sha-na-na-na-na. Sha-na-na-na-na-na-na-na. I think blue and green is too similar. But anyway, you can see that reflection over the origin again. So what's tan of negative x? Negative tan x, opposite, or theta, sorry. Just thinking about that x when we first learned even and odd functions with algebraic, like polynomials. That's when you first learned it. Okay, and then I believe we've written this before. Hey, go ahead and do this anyway. And in a unit circle, who is y? That's the sine of theta. Who is x? That's the cosine of theta. So this might be one more replacement you might need to do in order to solve stuff here. And then what does that mean cotan is? Flip. It is x over y. That means this flips. Okay, so really get this done. Cosine, and by the way, the brothers or sisters follow the same rules. So cosecant of negative theta is negative cosecant theta. Secant is the same as cosine. Cotan is the same as tan because they have the same rules about quadrants and signs, S-I-G-N-S. Okay? Oh, one more. I love this one. What time is it? Can someone look? Huh? 10:11. Hey, we know the Pythagorean theorem is a squared plus b squared equals c squared. That's the shirt I should have wore. All right, but I think I wore that not too long ago when it wasn't Jesus. Remember you guys said that? The picture of the guy here? I shouldn't say that, right, in a public school? But anyway, it was Pythagoras, and nobody cares. I don't care. And who's the other guy? E equals mc squared. Einstein fighting over c squared because it's in both formulas. Okay, anyway. When we go into a coordinate plane, wouldn't you agree that it was x squared plus y squared equals r squared? Didn't you do that a lot? Like a month ago when we first opened up. A month ago, we got back from break, and I did the Get Triggy with a song right away, right? Remember that? Anyone still watch that and dance at home? Good. Someone shook their head. Okay, now, here's how you derive this into trig. I'm going to write and erase. The first one I'll break down, all right? Whoa, whoa. All right, no one knows that reference. So if I divide both sides by r squared, why? Because I can. Whatever you do to one side, say it. And by the way, division is distributive. So if I divided the left side by r squared, each individual part gets divided. I can't go far. I got this. He's not here. And this happens every day. And sorry. Remember I screamed? Oh, you weren't out there when I screamed in this class one day. Yeah. You want some food? We apparently got food here too. All right. X over R plus Y over R equals, what's R squared over R squared? 1. Hey, and then what is defined by x over r in units or the circle? What trig function is x over r? Cosine. So if I had some drawing, and the drawing, and this was x, this was y, this was r, then this is theta. So now I can make a connection with x over r. That is the same as the cosine of theta. And then y over r is who? Sine of theta. And I think we've had this before where I've wrote this notation, but maybe not. And I got really bad spacing here. Sorry. And then that equals 1. And then this notation is written like this. It's actually written like this. Cosine squared of theta. Instead of the cosine theta then squared, they like writing it like this, which is less parentheses. But it means the same thing. You got it? And then plus sine squared of theta equals 1. So this is a Pythagorean identity converted into trig because of how angle